Okay, so there are going to be some problems where you can easily find the signs of the polynomial at different places without even having to really do much work at all. So there might be a few problems like this in your homework where they're kind of checking to see if you might notice. So this is a perfect square trinomial. It's 2x minus 3 quantity squared. If you happened to notice that, you'd be able to answer these really quickly. Because for part A, it says, when is that polynomial less than zero? It's never less than zero. So it's always positive because it's a perfect square. On part B, when is it less than or equal to zero? Well, it's never less than zero. We just stated that, but it does equal zero when x is equal to 3/2. So the solution set for that would just be 3/2. For part C, when is it greater than zero? Well, it's always greater than zero, except when it equals zero, which is at 3/2. So for this one, you would say negative infinity up to 3/2 union 3/2 to infinity. And then part D, when is it greater than or equal to zero? And that is everywhere. So that would just be negative infinity to positive infinity. Okay, we're going to talk about rational inequalities now. Um, we have the uh, picture here, the graph of the function 2x minus 5 over x plus 2. And you can look at the graph to see what's going on in these different places. So 2x minus 5 over x plus 2 is less than 0. That only happens this part of the graph where it's below the x-axis, and that happens as x. So there's an asymptote of x equals -2. So from -2 up to the 0 of the function, which is at 5/2. So that would be the solution set for that one. We're not including 0. So the solution set for that would be from -2 up to 5/2, not including 5/2. For 2x minus 5 is greater than 2x minus 5 over x plus 2 is greater than 0. You can see that that happens on the left side of the asymptote. So from negative infinity up to -2, but not including -2 because the asymptote is not something that the graph will ever touch. And then it's also positive from 5/2 up to infinity, but not including 5/2 because we don't want it to equal 0. And then 2x minus 5 over x plus 2 is less than or equal to 0. That is, we already know that it's less than 0 from -2 up to 5/2, not including 5/2, but it is equal to 0 also at 5/2. So we would say -2 up to 5/2, and this time we would put a square bracket on the 5/2 to include it as a place where the function equals 0. And then when is the function greater than or equal to 0? That's going to happen from negative infinity up to -2 when it's on the left side of the asymptote. And then also from 5/2 up to infinity, including 5/2 this time. That's if you have the picture. If you have the graph, you can figure these things out fairly simply just by looking. But when you have just the equation, you can't really do that. So we're going to see what we would have to do to solve this inequality. So the first thing we need to do is get everything on one side. So we are going to subtract 3 on both sides. 4x minus 5 over 2x minus 2 minus 3 is less than or equal to 0. Now we need a common denominator, which is x minus 2. So we multiply that 3 by x minus 2 over x minus 2, and then we combine those fractions and simplify it, and we have x plus 1 over x minus 2. There are two significant places we need to pay attention to. We know that the solution set, first of all, is all the x values where the function, that is f of x or y, is negative or 0. That's what we're looking for here. which means below or on the x-axis. That's just a reminder that that's what we're doing when we find the solution set. All right, so there are two issues here for this equation, x plus 1 over x minus 2 equals 0. The function is undefined at x equals 2, so that's where the asymptote is, and it has a 0 at -1. That is, it has an x-intercept at -1. So it crosses the x-axis at -1, and it will change from positive to negative or from negative to positive at that point. So those are two important spots. Everything else we will just look at in terms of these three intervals. We will talk about the interval from -infinity up to -1, the interval from -1 to 2, and the interval from 2 to infinity, and we'll see what the numerator and denominator look like in those different intervals. So on the interval from -infinity to -1, we can see, if we try -2, we can see that the sign on x plus 1 is going to be negative. The sign on x minus 2 is also going to be negative. And so negative divided by negative is positive. So the sign of the function in that interval is positive. From -1 up to 2 in that interval, we can try 0 in each in the numerator and denominator. And when we do that, the sign of x plus 1 will be positive and the sign of x minus 2 will be negative. So that means that the function itself will be negative because multiplying positive times negative gives you a negative. From 2 to infinity, both the top and the bottom are going to be positive, and so will the whole fraction, the whole function will be positive. So the only time that this function is less than 0 is when you're going from -1 to 2, and it actually equals 0 when you're at -1. So your solution set is going to be from -1, including -1, up to 2, but not including 2 because 2 is an asymptote. First thing we have to do is get everything on one side. So we're going to subtract 1 over x plus 3 on both sides, and then we're going to get a common denominator, which is x minus 2 times x plus 3. And then when we add everything up, we end up with 5 over x minus 2 times x plus 3 is greater than or equal to 0. Now we know that there are two significant issues here. The function is undefined when x is 2 and when x is -3. So we are going to have to look at the intervals from -infinity up to -3, from -3 to 2, and then from 2 to infinity. So those will be our intervals, and we're going to look at each factor in the function. We've got a 5, we've got an x minus 2, and we've got an x plus 3. 5 obviously is always just 5, so it's always positive. The sign of x minus 2 on the interval from -infinity to -3, it is negative. From the interval on the interval from -3 to 2, it's still negative, and then from 2 to infinity, it's positive. The sign on x plus 3, when you're in the negative area below -3, that is going to be negative, and everywhere else it's going to be positive. So you can see that for the first interval, the function will be positive because it's positive times negative times negative. For the second interval, from -3 to 2, we have the negative for the function, and then from 2 to infinity, the function is positive. So the question is, what are the possible values of x where this is greater than or equal to 0, and that's going to happen as you go from -infinity to -3 and from 2 to infinity. So here are some more rational inequalities that we can solve by just inspecting them. We don't even really have to do any work because you can see quickly that this function right here, x squared over x squared plus 4, is always positive or 0. The only time it equals 0 is when x equals 0. And it's always positive other than that because the numerator is something squared, which is always positive. The denominator is something squared plus 4, which is always positive. So this function is always greater than 0 or equal to 0, doesn't matter what number you put in there. So the solution set for this one is just going to be -infinity to infinity. For part B, it's always greater than 0 except at that one place where x is equal to 0. So we have to exclude that in this part B because it says only greater than 0. So we're going to say -infinity to 0, and then union 0 to infinity to show that we're not going to include 0, but everywhere else, that thing is positive. On part C, you've got when is it less than or equal to 0? Well, it's never less than 0, but it is equal to 0 when x is 0. So that would be our solution set for that one. And part D, our solution set would be the empty set because this function is never negative.